Hello everyone, my name is Patrick. I work for Snowflake. I've got a bunch of things I want to cover today, mostly around Data Vault, how it fits into your Snowflake environment and how to get the best out of it. So, got a lot to cover, I'll just jump straight into it. First of all, the definition, straight from the inventor's mouth. Basically, it's an enterprise vision of information delivery and business intelligence, right? What's really important about that sentence there is the word enterprise vision, which I'll show shortly. Also, since the Data Vault has been proliferated into a lot of industries and a lot of businesses, Bill Inman himself, if you're familiar with who he is, the father of the data warehouse, updated his definition of what a data warehouse is. And what he's changed in his definition is by inserting the word business key. So the data warehouse's objective is to gather data around what we consider is a business key that represents business objects, right? So a little bit about enterprise vision. So whether you're a small business or a large enterprise, there is always enterprise architecture, even though maybe a smaller enterprise wouldn't call it that, but definitely large banks and large energy companies would call it enterprise architecture, right? But whether it's FIF, TOGAF, DODAF, or any one of these frameworks, what you'll find in these enterprise architecture frameworks is that the very first thing they talk about is business architecture. And every other architecture after business architecture is simply just automating what that business architecture is, right? And from a business architecture perspective, what we talk about is splitting up a business into capabilities. So if we talk about a huge insurance company or any sort of insurance company, a capability would be something like policy management, claims management, case management, any sort of thing that a business does is a business capability. But what's also interesting about that definition is that a business capability will be around and about a business object, whatever that is. If we talk about policy management, it would be a policy, right? And how do we identify a policy? We have a policy number. Or a claim would have a claim number. Or a case would have a case ID. There's something that we attach to that business object that gives you that immutable key that we can track information against. We can track what it's related to, which is really important to a business, policy and account holders and policy holders and who's the owner of the claim and so on. And we also, from an enterprise perspective, want to track what's the state of those relationships and those business objects, right? So that's really important to keep in mind because then it'll emphasize itself in the Data Vault perspective. So straight into what a Data Vault 2.0 is. When you speak to any sort of Data Vault practitioner, they will talk about the three pillars of Data Vault. There are the data modeling blocks that you use to represent those objects. There's the implied agility, as well as there's the recommended architecture. And from an architecture perspective, on Snowflake, for example, it's no different to what we're used to. We're landing data from the left-hand side, we're integrating it somehow, and we're delivering information, analytics, and value to the consumers, right? Now, what's different here is that integration point is represented by the Data Vault. So from a Data Vault perspective, you would model the raw data into a raw vault objects and extend that raw vault by soft business rules that's then represented by a business vault. The business vault is implied to be sparsely modeled. So you won't have everything going through a business vault. You will have those business rules that you could not solve in the source system. And the source system is nothing more than just business rule automation engines. And that's what the job of the Data Vault is to bring that together. And the consumer layer would be covered by things like information marts, dimensional models, and so on, right? So the building blocks, really easy, just 3 table types. We have hub tables, link tables, and satellite tables. And basically, a hub table is a unique list of business keys. A link table being a unique list of relationships between those business objects. And then the satellites look like SYD type 2 tables in a dimensional model, but basically they're tracking the change data against that business object or that relationship. And just to see what it looks like, my clicker's not working. There we go. I'll introduce a business capability example, right? Who knows what a potent potable is? You can shout, no microphone. What is a potable? Alcohol. Yes, thank you. So this is an example of alcoholic distribution business and the various capabilities that it does, like stock management, distribution management, batch management, product management, and so on. So if we were to superimpose that with a data vault, we'd start off with what are those business objects that we are tracking. So we'd model them as hub tables, hub distribution, hub stock, or hub what have you, which is nothing more than a store of unique business keys, right? And those business processes are then tracked with those link tables. That's the interaction, the transactions that happen between business objects. And then we can extend that with the satellite tables, which track the change information about those business objects and relationships, right? So you can already start to see there's going to be a lot of tables that you end up joining. Data Vault also comes with patterns to get the data out, which from a Data Vault perspective we call query assistance tables. In the community they're called pits and bridges. So a pit table is just nothing more than a point-in-time abstraction of the keys and load dates required for your dashboarding and your analytics, right? We typically surface those into a pit table and then build views over those as information marts. So as soon as the pit is updated, so is the information mart. And the bridge table follows the same pattern, bringing in those keys and then building information marts that are then based on those artifacts. From a data engineering perspective, of course you can automate pits and bridges, but the real automation magic sort of happens in the ingestion of data into a data vault. So as I said, you can bring in data at any cadence. It could be batch, micro batch, streaming ingestion, and the data is then landed, or if it's streaming, it's taken straight through into the tables. But along the way, when it's staged, it's typically deployed as a view, and that view then adds all the Data Vault metadata tags required for your Data Vault model. Things like surrogate hash keys, or load date timestamps, or hash digests for that record are then added as a view. And then because you only have 3 table types, you only have 3 loader types. What are the new keys? What are the new relationships? And what's changed about the data that are brought in? And that's checked against the active record in the satellite. So just want to highlight, at the vault artifact level and the stage level, there are 3 lines there. That symbol is representing Snowflake Stream. And I'll quickly explain how that works. So a Snowflake Stream is nothing more than a bookmark that you add to an object, right? And that bookmark is queryable. You can select star from that bookmark. You can see what's it's tracking at that point in time. But as soon as you use that bookmark or that stream as part of a DML statement, you're essentially taking that data, processing it through whatever your select statement is doing, and loading it to a target table. So that's a really neat way to actually just process what's been added to that source data to a target table. And you can have as many streams as you want against a landed table. So what it looks like for our Data Vault pattern, let's say we have just a hub and a satellite. You essentially create a stream on top of a view, and what Snowflake will do is then deploy that bookmark against the tables that make or support that view SQL. What this also implies is that you can be landing as much data as you want, and then separately, autonomously, load data from that landed content. So there's no dependency between the two. It's just, land as much as you want, and then when you need to, load that data into your vault, right? As an expanded example, let's say you've modeled a link to hubs and satellites. What this is showing is that, I mean, you can load as much as you want in parallel. There's nothing that's forcing you to have a staggered load between hubs, links, and satellites. The keys that are used to join those tables together at a later stage are deterministic surrogate hash keys, or you can use natural keys if you choose. And if you have a modeling pattern, well, let's say that you have a link and two business objects that are actually loading to the same hub table, the way to manage that within Snowflake is very easy. You don't have to actually lock that target table. Instead of doing an insert statement into that target hub table, you just turn that into a SQL merge, and Snowflake will lock the entire table without explicitly saying lock, unlock. It would then cater for the multi-threads trying to hit the same table and allow one thread to hit that table at a time, right? Very easily, no special mechanics behind it, just use a SQL merge with a not matched clause insert to the target table. So that's all great, building data vault models, but actually the vision behind a data vault is bringing all that data together. So in fact, when you're modeling towards a data vault, you're building what's called passive integration, or towards passive integration. What this gives you is that since you're bringing all this data from different sources, that you're integrating against the hub tables themselves. And that gives you that customer 360 view of what's happening on policies and claims and insurance and so on from different source systems, not just a single source system, right? And this is what is implied by the agility behind a data vault. So you can have domain owners working with stream-aligned teams that are building towards their own data vault portions. However, there's still a level of governance. You know, what are the naming standards we're using, making sure that we're loading the correct keys, the correct hub tables through, let's say, an enterprise standard for what those things are, representing what that enterprise vision is. And the way we cater for that, if we were loading to shared hub tables, we would cater through three scenarios that are not mutually exclusive. You could be loading different contexts to the same hub table, or if, let's say, you have an MDM source system that's helping you with mapping between sources and an MDM key, you could be mapping it to that single hub table and supported with a link table. Or let's say that you have a business key that could represent two different business objects, the same value, then the way we would cater that for in a data vault is include sort of a tiebreaker value, which we call a business key collision code, and you would end up with two entries for that business key, but different business objects. And that's to ensure that when you're joining against the rest of the data, you're not joining against the incorrect data. So there's other patterns from a data vault perspective. They're still based on those three key table types, right? If you had multi-active records that are active at a point in time, there are patterns in Snowflake to deal with that, multi-active satellite, dependent child keys, as well as how we deal with ingesting streaming data. In data vault parlance, they're called non-historized tables. We also cater for patterns to deal with data that arrives out of order, out of sequence. For example, if on a Thursday, Tuesday's data arrives, but actually you've already processed Thursday's, how do we then deal with that dynamically? And we have modeling patterns to deal with that efficiently. Status tracking, record tracking, things that we actually add to the data vault to track what's happened to that business key itself. Has the customer disappeared from the source system? When's the last time we've seen this business key arrive? Do we consider that a business key that hasn't been active for 3 months? Is it still a living business key or something we have to investigate? Effectivity satellites to actually track which is the active relationship between business objects. Because as I said, a link table will give you that unique list of relationships. If you have a flip-flopping relationship where it goes back to the previous relationship, how do you then track that? And that's what the effectivity satellites there is for. And then the classic ways of getting the data out. You're not restricted to just pits, bridges, and informarts, but these are specifically designed to take advantage of Snowflake's OLAP capabilities, right? So building the pit that's used to bring in data from satellites is similar to what you would do with facts and dimensions. And if you run that on any platform, Snowflake included, it will do a right deep join tree and efficiently get that data out for your analytics, right? And of course, recommend the team. Each team should have some sort of responsibility and ownership to deliver the data vault model in portions, as you will. What is important, of course, is that you have a source system SME on hand, somebody who can help you actually explain the concepts as is delivered from the source system, because sometimes it doesn't quite fit in how the business sees it. So you'd need somebody like a source system SME that help you and guide you to build out those data vault objects. And at the end of the day, this is the vision. Passively integration, eventual consistency, and just simply loading data in as you've modeled them at any time of day without restriction. And that's my talk. The QR codes are more resources on Data Vault on Snowflake, artifacts, and there's a webinar too, the last one there, Zero to Data Vault on Snowflake.